Bhupen sir, your voice is not clear, sir.
So I would now invite Prateek to give a brief introduction of our eminent speaker today.
Am I audible, sir? Okay. Can you see my screen? Okay, fine. Now, can you see the screen? Okay, fine. So once again, good morning to all of you. So today, I am just going to discuss about the ANN, and this is the artificial neural network. And I came to know about the audience that they are new to this field, and that is the soft computing. So I'll give you the brief. I'll not go to the very detailing of ANN. I'll give you the overview of that how it works and what are the basic components of the artificial neural network.
Okay. So here you just see what we have to calculate the total current. You just see here in each case the current is flowing I1, I2.
Hello, am I audible? Yeah, I hope I am audible. Yeah, so this is the just I am giving you the overview of the artificial neural network. The main concentration of this session will be on that how with the help of the different tools we can apply the artificial neural network and how it can be used to solve the real world problem. Because ultimately, the motive of any technology is to solve the problems on the daily basis, whatever we are facing. So, artificial neural network, as you can see, the processing of the brain as a basis to develop the algorithms that can be used to model the complex patterns and prediction problems. So nowadays the data is very important. You gather the data and you can predict the future aspects. So I mean to say that if the stock is there, any particular disease is there, for example, if I can take the COVID-19 only, daily you can see the update on that particular pandemic, and you will find to know about that what will be the trend in the future in a particular region like Europe, Africa, Asian countries, how it is happening. This is because of the advanced soft computing technologies, and these soft computing techniques under the umbrella of AI, they are using the artificial neural network, the deep learning, and the machine learning algorithms. Artificial neural network just behave like the human brain. The human brain is composed of the billions of the neurons. At each neuron, the information is processed, and that is conveyed to the next neuron in the sequence. In the similar manner, we have to build the artificial neural network. How to build it, that we will see. So before going to that, I'll just show you that human brain. Here you can see the synapse, dendrites, and axon, and some. These are the neurons actually, and here dendrites are taking the information. This taking the information in the computational term known as inputs. So these dendrites are collecting the information in the form of the electrical waves, and then they are processing at the neuron, and through the axon they are passing this information to the subsequent neurons in the sequence. This is a very overview of the human brain I am giving you. That external information or the stimuli is received by the dendrites, processed by the neuron, and passed through the axon to the next neuron. Now these are the 4 steps whatever I have explained to you. This is the external signal, processing, and conveying to the next neuron. Now based on these 4 steps, you can just go through the ANN architecture. Architecture is also collecting the information, it is processing, generating the output, and conveying to the next neuron in the chain. So this x1, x2, x3, you can see these are the inputs. This analogy you can match with the previous diagram, that is this one, the human brain cell diagram. Here also you can see in the orange color, those are the 2 different neurons. They are connecting by some axon, and one neuron is processing and it is passing the information to the next neuron. Just similar to that one, x1, x2, x3 are the input signals, and these signals are received by the dendrites of the neuron. Now these neurons are multiplied by some weights, and these weights are going to generate the output, and after doing that, this output will be based on the activation function that will reach to some threshold, and it will process the inputs, generate the output. So in a very simple term, if I want to explain this ANN, So I'll tell you that neuron is a centralized tool in the artificial neural network I am talking about. That particular centralized device is collecting the inputs, and based on the activation function it will generate the output. So this is the overall structure of the artificial neural network. So I'll try to explain this with a very simple example. And W1, W2, W3 are the strength of the input signals, that how these input signals are working, how they are weak, how they are strong, and which input is going to contribute, which input is going to contribute. If I want to explain the weights in the ANN, so a student is going to score high or low marks in the examination. It solely depends on the how much time he has devoted so to his studies. So if he has devoted enough time, then output definitely result will be fine. Otherwise, he is not going to score much in the examination. So this is the weight. So input depends on the strength of the weight. How much weight you have provided to that input, that only going to impact the output. That's what it has been mentioned here, that W1, W2, W3 gives the strength to the input signals. If we have not given the enough strength to the W3, then output will be decided by the W1 and W2. So here one example I have taken. In that example, a bank wants to assess whether to approve a loan application to a customer now. So to approval of the loan to the customer will depend on the different input parameters, like what is his credit score, what is his age, and all these parameters. So like customer ID is there. So we don't need the customer ID for deciding whether we have to give the, or the account number is there, suppose. And that account number does not decide that whether that person or the customer is liable to get the loan or not. So we will not give much importance to that input. We will give the importance to his credit score, his account balance, what is his age, what is his job type, what is his income. These are the important. So weight, according to the weight only, this will decide that how this particular system will behave. Now here in this particular example, I have the 1, 2, 3, 4. These 4 inputs I have: one customer ID, customer age, debt ratio, and the monthly income. And this is the actual output, actually the loan defaulter. If based on these inputs, we have to just predict whether that customer is defaulter or not, or will we have to give him the loan or not. So 1 is yes, he may be a defaulter, and the 0, no. So the last column, that is the X. This X in the probability, that is ranges from the 0 to 1, is predicted by the artificial neural network. If you can see the column W, this column W is the actual result. So based on the training data, we have to test the data and we... Hello, am I audible?
अच्छा
Hello, am I audible? Yeah. Please ask the participants to mute themselves. Yeah. So this W, yeah. So this W is the actual output, and this X is the predicted output by the ANN. So if this X is very similar to the W, that means our artificial neural network is predicting very perfectly. As you can see, the lone defaulter in the W column is 1, whereas the prediction column X is 0.76. So it is very near to the 1. And the 0 you can see 0.34, we can set the threshold as the 0.5. Above 0.5 it will be 1, and less than 0.5 it will be 0. So except one case, that is the fourth row, our particular ANN is behaving in a good manner, and it is generating the current rate. For the sixth row also, it is, you can consider. Okay, so out of 6, the 4 has been predicted well, the 2 has been predicted wrong. So this is the accuracy of the ANN model. So how it will work? That earlier the 4 inputs were there: the customer ID, age, debt ratio, and the monthly income. Out of that, we have taken only 3, and these inputs are processed here with the different weights. So we have here the 2 neurons, or the hidden layers, you can ask about that. In between the output layer and the input layer, there are certain hidden layers, and these hidden layers, what they are doing, that they are processing the information and they are getting the essential information about the inputs. According to the essential information about the neurons or the inputs, it will inform to the next layer into the sequence, and it will try to minimize the error. What is the error here? That actual lone defaulter output for the first row is 1, but it is predicting 0.76. Actual output for the lone defaulter in the sixth row, it is the 0, and the default prediction is 0.72. That is reaching to the 1. That means some processing in between of this in between this output layer and the hidden layer, it is not corrected. So according to this error, they have to correct their inputs, their weights. Again, they have to process the information. Again, they have to generate the output unless and until it is not reaching to the required target. This is known as the learning of the artificial neural network. That is, this is my target. I have processed the information. I have checked this information and intermediate output with my final output. If my final output and this achieved output are not matching, that means some problem with my processing. I have to change the weights of my inputs. Again, I will change my inputs and their weights, and I will come to the output. If my achieved output is equal to or near to the targeted output, then only I will accept that input and with corresponding weights. So hidden layer will give the input to the output layer. So this is the overall architecture, and in each hidden layer, the processed inputs are converted to the output, intermediate output, with the activation function. These activation functions are very important function, because upon reaching to a certain threshold only, this activation function will activate the architecture. As you can see, that there are 3 layers: input layer, hidden layer, and the output layer. If you have more than one neurons or the more than one layers in that particular architecture, then it is known as the multi-layer perceptron, or multiple layers are there. Hidden layer, it is known as the distillation layer also, that it distills, it it quantifies the some important patterns from the input. That inputs are very important for the output, and that we are going to process in the next layer. So it's not like that what was the raw data. That raw data has been processed, and out of that processed data, whatever the important information we have achieved in this current layer, that only we are supposed to pass to the next layer. Then the next layer will receive the processed information. Further, it will process the information, and it is going to forward it to the output layer. So this makes the learning fast. This makes the learning of the network fast, and important information only gets the weightage. All the redundant and the non-important information are the filtered out in the subsequent processes. So this activation function activates the output. So if two inputs are there, two corresponding weights are there, and suppose the threshold, the activation function has reached the 0.5. When we are multiplying this inputs with the corresponding weights, and it is reaching to the certain level, and if it is crossing the set threshold value, then only this activation function will activate that output based on that input, and it will generate to the output to the next subsequent layer. So activation functions are very important in this field because it captures the non-linear relationship between the inputs, and it converts the input into the more useful output or the more processed output. So subsequent layer should not get the redundant information, non-important information, the proper information that is useful for the subsequent layers. And this is the activation function role. So in this example, we have using the sigmoidal. It will generate the output between 0 and 1. We have multiplied all the inputs with the corresponding weights, and then it will activate between the 0 and the 1. Others are like if we have the, in this case, we have only the two outputs, that is the 0 or the 1. So we can use this simple sigmoidal function. If we have the multiple classes to identify, then we can use the softmax. For the hidden layer or that ReLU, that is the rectifying linear unit, and that is used, and softmax also we can use. So this is the this F1 this F was for the first hidden layer, the F1 is for the second hidden layer, and O3 is the final output, that is the final for the row like 0.75 is there, then it is closer to the 1. If it is less than 0.5, then it is closer to the 0. 0 and the 1 is the predicted class, and it will predict. So weights, I told you, are paying the most attention from the data scientist, because the weights, there is no thumb rule for the deciding the weights. It's a hit and trial method. So you change the weights. If you are getting the required output, then it's fine. If you are not getting, then you have to change the weights and you have to manage accordingly. So here, what we have learned, that subsequent layers are passing the filtered information from one end to the next end, from one layer to the next layer, till the output layer. This known as, because we are just going forward from one layer to the next layer. We are calculating the processed information with the already set output. So this is known as the feed forward network. But when this comparison of the output with the subsequent process inputs or the intermediate outputs happens in the backward direction also, that is from the output to the input layer, that we known as the back propagation algorithms. That is the learning algorithm. We are learning from the errors, we are improving the model, and we are getting the optimized value of the weights. because optimized value of the weight only can minimize the prediction error. Maybe this time our model is predicting the 0.75 in place of 1. We have to reach to near to the 1. This time 0.75, next time 0.77, next time 0.83, next time 0.9. Like that we have to manage the weights and we have to minimize the prediction error. The most common method for use for the weight optimization is known as the gradient descent. What this gradient descent is doing, that it is using the different values of the W, and W means weight, and then it assess the impact on the output or the prediction, and finally which value of the W are optimal, that only it will consider, rest it will overlook. If you want to go through the details of how the gradient descent algorithm works, this is a good source of it. So I'll share this PPT with you all. You can click this link and you can go to the details of the gradient descent. For now, I want to tell you that gradient descent is the algorithm which is used for optimizing the weights, so the prediction error will be minimized. So what are the advantages? So here the advantages, we can learn, the model can learn fast. What the human cannot understand, the complex relationship between the inputs or the non-linear relationship between the inputs. It can understand, it can process. ANN can be generalized, and for the unseen relationship, unseen data, unseen pattern, it will predict. So you give the training, you can give the training to your model. Please unmute yourself. Yeah. So unlike other prediction techniques that does not impose any restriction on the input variable, so you can give any number of the input variables that will be processed and that will be given to the output layers, and you can see the results in the for the unseen input patterns you can get the results. Okay, so it's like if you have the 60 students in your class, you collect the data, how much time they have studied and what chapters they have studied and what is their final output. So you have trained your artificial neural network with the 60 students work commitment and their results. Now the same model is ready. Now the model has learned if someone has studied the 5 hours in a day, the result is different. If someone has studied 1 hour in a day, the result is different. Now the same 60, the model training happened with the 60 students. Now the same pattern you are supposed to apply for the class B. This time the class B, we are not going to collect the data. We are just collecting data about their number of hours devoted for their studies and what portion of the syllabus they have covered. And your model will tell what will be the result of the student. So this way the artificial neural network, it needs the training, it collects the data, it collects the sample, it trains itself for certain number of inputs, and it predicts the class, whether the student will be pass or whether the student will be fail, whether we have to give the loan to the customer or we don't have to give the customer, whether tomorrow will be rain or not, whether this guy is diabetic or not. This kind of predictions artificial neural network will do. So this is FF and FB network. If the processing of the information is in the forward direction, it is known as the feed forward. If we are getting it in the both the direction, then it is the feedback network. Applications are many. One of them is the image processing, character recognition, and the forecasting. So here I'm going to cover a case study on the PIMA Indian diabetes prediction. Actually, in Arizona state, one hospital has conducted the case study of because they are from community ladies were diabetic, and from that community only the more diabetes cases were noted. So they wanted to conduct the survey and they wanted to gather the information why this is happening, and they have decided certain parameters. So it's a chronic disease, and particularly it was happening to the particular community. So they conducted a certain study based on few parameters, based on few inputs and few attributes, and then they have identified that whether those ladies are diabetic or not. So these are the diabetes, as you know, it is divided into the two parts, the type 1 and the type 2. So this data set is available on the Kaggle website. I'll share the link from where you can download this data set also. This data set is originally from the National Institute of Diabetes and Digestive and Kidney Disease, and it can be used to predict whether a patient has diabetes or not. And these diagnostic factors will work as the inputs for the artificial neural network. So this is the prediction methodology. So how the prediction methodology works, you have to load the data, you have to pre-process the data. As we already discussed, that key for working of the neural network, and we need to process it before feeding it to the neural network. Before going to this point, I'll cover some important processing of the data science, what it happens in the soft computing data science process, how to pre-process the data and why this pre-processing is needed. I'll just tell you. Okay, so we have to visualize the data, we have to get the insight from the data, and we have to check whether the data is appropriate or not. Because as I told you, any prediction model depends on the quality of the data. If the quality of the data is not good, then the prediction of the model will not be good. Your prediction will be wrong. So you can allow, and the subsequent and the consequences will be there if your model is not predicting correctly. So anything can happen in the prediction, and your complete business model is depending on your prediction of the model. So this is very crucial that before starting the actual processing, we should pre-process the data, we should clean the data, we should manage the data in that way that model after processing it should predict the correctly. If it is not predicting, then it is very harmful. So a person who is diabetic, if your model is predicting that he is not diabetic, then you can see the consequences. So this is the way the pre-processing is very important. Then you define a model, how many layers will be there, how many hidden layers will be there, how many inputs you want. Maybe in some cases some 30-40 features are there, input features are there, all input features are not important. So you need certain number of features only, so that shortlisting of the features is very important. And then how many hidden layers are needed, whether you have to go for the feed forward network or the feedback network, all these things you have to manage and you have to decide. And after that you have to think about the output size, whether it is the binary output or it is the single or it is the multiple class output. So you have to pre-processing the data, you have to define the model, and then you have to see the optimizer and the loss. As I told you, there is no thumb rule for deciding the weight. So you decide the weight according to the loss. If what loss is occurring, that you have to make into the account. If the loss is less, your parameters are fine. If not, then you have to revisit your hyperparameters for the optimizing the input parameters, weights, on the loss function. And the fit model, once your model is ready, you have to fit this model for certain amount of the data that will known as the training data. So you are training the data. As in the previous example, I told you that we have applied the model and we have trained our model on a class A of the 60 strength, and then same after training the model, we are applying the same model on the class B, and we are predicting whether the boy or the girl is going to pass the exam or fail the exam. So training step of the neural network is very important. It defines the number of epochs. So this epoch is a keyword, and what is the epoch means that how many number of times you want to train your model. Okay. So this is the epoch. It decides that how many number of time you want to. One more thing is there, that is known as the batch. Among the training data only, how many batches you can create and you can give it to the model for learning purpose. If the learning will be good, then it will be good for your model. So we should train the model with the sufficient number of the data samples. So if any unseen or the unseen pattern or the unseen data encounters in the processing, the model should be able to predict properly. Okay. So this is the process. You have to set the research goal, actually what you want to find out, and this is the additional information which the agent is required. Hello, please unmute yourself. So after setting the research goal, you have to retrieve the data, you have to prepare the data, you have to do the data exploration. This data exploration is nothing that is the pre-processing data. Before processing the data, you have to see whether the what data tells, what information you can get from the data, and how to model the data. And the last step is the presentation and the automation of the. So you have to define the research goals. The context of the research should be appropriate. You have to prepare the project charter, retrieving the data. After retrieving the data, you have to clean the data. This is very important thing. The clean the data means by mistake, the people are forgetting about entering the data. So like suppose you are collecting the data for whether loan should be given to the customer or not, and what is his income, we forget to mention there. So if the data is not there, the model cannot predict. So better way to learn is you have to clean the data, whatever is the missing data is there, then you have to enter it properly. Now we are collecting the data in the rupees. Someone has entered into the pound. This is also the erroneous data. So we have to clean the data like this. So the first case we have seen, if by mistake someone forgot to make the entry. Now what entry we should make? This is very important task. Suppose we are collecting the data in the rupees and someone has entered that data in the dollar or the euro or the pound. So then we have to make the conversion properly. Okay, outliers are there, impossible values are there, redundant white space is there, misleading values are there, and suppose we want the income and someone has entered the female and the male option there. So female and male are the valid option, but not for that particular column, it is for the other columns. So it is the mistake during the data entries. We can check the impossible values. If we are asking for a customer loan and we are asking for the customer income, and that customer income has been written as the 1 crore rupees per month. If he is earning 1 crore rupees month, then why he should apply for the 1 lakh or the 2 lakh rupees loan? So these are the impossible values by mistake entered into the column. So that also we have to clean. So these are the general solutions for the manual overrules, use string function, manual overrules, and you have to clean the data in short. So cleansing the data, as you can see that one outlier in the graph you can see, okay, such outliers are not required, which are deviating from the normal pattern. You have to remove those outliers because those outliers are of no use. So we have to just get rid of those outliers. I'll not go through the details of all these things. I'm just giving you. So this is, as you can see in the graph, we have expected distribution. This is the normal distribution, but the two vertical bars at the end, as you can see, they are clearly outliers. Such outliers in the building ANN model we have to remove. Then only we should give the data to the ANN model. Missing value is there, we have to provide the appropriate value. Okay, so these are the different things. Transforming the data. This is also the transforming data. So if we are working on the actual data, then actual data is ranging from the linear y, as you can see in the different values. But if we take the log of that one, then we will get a straight line. So sometimes the transformation of the data to a particular range also is very important. So exploratory data analysis, you don't do anything, just you see the pattern of the data in the pie chart, in the histogram, in the box plot, in the line plot, in the scatter plot. That graph only will tell you many things about the data. So first of all, what is the process of building the ANN model? Before building the ANN model, you have to be clear what kind of data you are providing, how you have seen the data, how the data has been understood by the owner of that data before building the model. It should be clean, no missing value should be there, it should not be erroneous data, it has to be pakka data, it has to be very clean, clear, and the understandable structured format. Then only you can build the application on the top of that. So this is what a short introduction of the ANN. Now I'll just go through the implementation part of ANN, how to build the ANN. If you want to ask something, you can ask in this ANN. Hello, am I audible? My screen is visible to you. Can you see the Jupyter notebook now? Okay, wonderful. Just 1 minute, it is loading.
चल साउंड असला
I hope my Jupyter notebook is visible to you. So, yeah. So, don't scared by the Python language, or if you are completely from the non-programming background also, it is fine, because what matters that you have to understand the flow of the work. You should know how to build the model. So before building the model, I have shown you that you have to process the data and you have to see that how it works. You have to get the insight from the data. Then in second or third step, the artificial neural network model comes. But before what comes is the data cleaning, data insight, data overview, data cleaning data which is missing the data. You have to fill those entries. Erroneous data, you have to correct it. All these processes comes, then the building the ANN model will come. So here, if you are not from the computer science background, then you are from the non-programming background, it's absolutely fine. Just be with me, just synchronize with me, and you will find it very easy. So the code piece, what I have highlighted here, that is the pandas, numpy, sklearn, seaborn, matplotlib, svm, neighbors, neobase, tree, decision tree classifier. All these are the tools and the algorithms. Like Panda is used to put everything into the table on the structured format. NumPy is the numeric pi. It's a Python tool that is used to do for some calculations and all those things. Seaborns and the matplotlib are used to plot the data. SVM, neighbors, neobase, tree. All these algorithms are used to build the model, or these are the classification algorithms. They are used to build the model. Now, just like whenever we are doing some yajna or the puja, we are just remembering the Lord Ganesha. Like that, you have to import this before building the model. This pandas, numpy, sklearn, trend test, split, model selection, SNS, matplotlib, all these things you have to include by import statements, and then you can proceed with this one. Now I am highlighting one more line, this particular data. This is the Panda read CSV file. Actually, data is collected into the Excel format or the comma separated values. So you read those CSV. So CSV will be at a particular location. You cannot go there and you can just read and work on the CSV there. So whatever the function you want to perform on your CSV file, it will reflect here. You can access the file and you can modify the file according to your need. So as you can see that data provided by the government agency on the diabetes, the PIMA diabetes, I have included into my data frame. This is the CSV file where all the data is there. This PD is the pandas. Pandas is a tool of the Python, and this read CSV is the method through which I can read the file. In this file, everything, the information about the diabetes has been given. I don't know anything about the file or the diabetes file, whatever I have. So what I will do, one function I will use here, and that function is known as the head function. That means I want to see the insight from the data set, that how many features are there, how many columns are there, what those columns are doing. So here, as you can see, by putting this head, the first 5 rows I can get from the my data set from my file. As you can see, the pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, body mass index, and this DFF, DPF, this is the function, that is the hereditary diabetes function, age, and these are the input parameters. So first lady they have contacted, they asked them whether you are pregnant or not. She has written 6. So means 6 times she got pregnant. What is the glucose level? They measured and they wrote. What is the blood pressure? What is the skin thickness? What is the insulin level? What is the BMI? What is the family history about the that this function gives the values. Okay, and this is the age, and this is the outcome. Outcome means whether she is diabetic or not. If 1 yes, 0 no, 1 yes, 0 no, 1 yes, 0 no. So pregnancy is glucose, BP, skin thickness, insulin, BMI, diabetes, pedigree function, age, all this will predict to the outcome variable. Okay, so this is the overview of the dataset head. But still I want to get the insight from the data. As I told you that before building the model data speaks a lot. What the data is speaking, we have to understand. So here we have that pandas profiling that gives the profile report about any data set. So before building the model, you should see that what that data is. So this data set information, by putting this file, by this profile report, what data I am getting here, that in my file there are 9 variables. I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Number of observations. How many surveys have been taken on how many samples? So this is only head. It is giving me only the information about the first 5 files, 0 to 4. But how many total observations or the samples are there? This is the 768 samples are there. Okay. How many missing data is there? No missing data. What are the variable types? So 8 numeric type, 0 categorical, boolean is 1. This is the outcome 10 10 10, and rest of the things are not there. Some warnings are also given. Now, warning has been given as the BMI, that is the body mass index. The body mass index is having the 1.4% zeros, or the blood pressure 4.6% zeros. That means 35 out of 768 total samples present in the file. 35 persons are there, 35 females are there where blood pressure has been measured as zeros. That means if someone's blood pressure is 0, he is not alive. Or someone's BMI is 0, that means he is not there. That means these 0 values are erroneous values. Okay. If the skin thickness is having the 0, that means it is erroneous value. So here I want to see that if I want to predict on the income, if I want to predict on the loan disbursement, if I want to predict on the weather outcome, then I should not include the missing data. If the missing data is there, then model cannot learn. Model will not have the sufficient number of the inputs and it cannot predict the output. So we have to remove these zeros. Now you can see the variables here. The age is providing something. What is the mean? What is the minimum age? So all the ladies are between the 21 to 81 age, and the mean is coming as 33. Distinct count is 52. The BMI and blood pressure, as you can see, all the graphs, all the histograms are saying something about it, except few like BMI and all these things. They are not behaving in the normal distribution. That distribution is not good. And the outcome, as you can see, that is 500 ladies are identified with non-diabetic and 268 have been identified as the diabetic. Now this is chart for the pregnancies, and this is the skin thickness. So almost what is the motive of our analysis? We have to make it a normal distribution. We have to remove the zero values, and it is fine to remove the zero values, but there also we have to be very careful, because blood pressure zero value you cannot accept, but for the pregnancy you can accept the zero values. So you are not going to remove this zero with some number, but definitely this number has been replaced by the zero with something else. Zero by mistake it is there. So you have to just make a careful observation for which features you are going to consider the zero and for which feature you are not going to consider the zero. So this is done. Then we have identified the impact of the each variable into the outcome variable. Outcome variable is what? Whether the person is the diabetic or not. So suppose in this way, if I am taking the glucose and I want to check whether the glucose is related to the outcome variable or not. This is my outcome variable. This is the scale has been provided from the -1 to the 1. This is the correlation matrix, and it shows if the light color is there, that means that variable is not much related to other variable. Like if I take the age, it is ranging between some 0.5 to the 0.75. Okay, so yeah, mediocre you can take it. Like very light blood pressure. So the blood pressure is not impacting the diabetes here in this case. If you can see glucose section color is very dark, and it is ranging from the 0.50 to 0.75, and it is directly correlated to the outcome. So this is the, or we can see the insulin also the related to this one. The BMI, you can see the BMI is also correlated to the outcome. So this observation gives us one overview that which parameter for building the artificial neural network we have to include, or what we have to exclude for the analysis, or for before building the ANN model. So data set is null. So we have to identify whether it should be no column should include, or no data column should include any missing value or the zero value, or if the zero is there, it should be appropriate. These are the columns. So you can just write the dataset dot columns. You will get all the columns. So we will just what we will do. We will just divide this outcome into the two parts, that is the 0 and the 1, and we will identify that how many glucose entries are there, and those entries are affecting into the 0 and the 1. So as you can see that we have to pre-process this data because many are reaching to the 0. So we have pre-processed the data and we have many missing values. As you can see, the 0 values are there. So we have pre-processed the data, and when it is the diabetic, no value is going to reach to the 0. Here the glucose value was reaching to the 0. It is physically, it is not possible for this is the medical diagnosis term. This is not acceptable parameter which is reaching to the 0 for the glucose. So we have to identify it with the proper thing. So as you can see, this start from the 0 or some minus values also. But after pre-processing the data with respect to the outcome variable, these ranges have been starting from some 26 or 27. And when it is coming to for the particular one, that is the outcome one, then it is reaching between this 50 and 75. So like that glucose we have processed the, see here, and when we have classified the blood pressure variable with the 0 1, and we are getting what? We are getting that some blood pressure values are reaching the 0 values. So this is erroneous. This is known as the violin plot. The lower end you can see it is reaching to the 0 or the negative values, and the upper values are reaching to the outliers or the highest values or the peak values. And this simple dot in between that, it is representing the particular mean value for that one, or it is deciding the range. Okay, so here we have seen the minimum blood pressure. It is identified as the 0, which is not acceptable. So you have divided based on the outcome, and then you have calculated the median. Median means in between that one, you can take the average, you can take the mean, you can take the median, you can take the mode, anything you can take, and you can replace these 0 values with the median. I have taken the most frequently used values with the 0. So 0 has been replaced by the most frequently occurred value in the data frame from the blood pressure variable. So it has been replaced. So after replacing, you can see the 0 values have been removed and this completely transformed. So similarly we have done for the skin thickness. We have done for all, I have taken the median. So if the skin thickness is having in the 0 category, that is not having the diabetes or having the diabetes, you have to replace with median value of all the values. So this is what I got for the skin thickness. This is I got for the insulin. This is I got for the insulin after pre-processing. Now there are different values. If I go above, and I can show you that skin thickness is ranging from the 35 to 3629. This is 33.6. This pedigree function is 0.6 to 7.351. Age is from 21 to 81. So there are the different readings for the different parameters. So one standard scalar method is there. That standard scalar method does what? It everything transform in between the 0 and 1. So I have using the standard scalar, or you can use the min max scalar, and then you have to fit your data. So here what you have done, you have y. So in the y column you take the outcome variable, that is the last column. On here you can drop rest of the things, and X will contain all the input features and Y will contain the outcome variable. Now your complete data set has been divided into the two parts, one Y will include the outcome variable, that is whether you are diabetic or not, 0 or 1. And X will include all the parameters, those are the input parameters. And you can transform that X, and that X after transformation, if you will take what happened to the age, it is in between the 0 and 1. BMI in between 0 and 1. Blood pressure in between 0 and 1. Diabetes pedigree function between 0 and 1, 0 and 1, 0 and 1, 0 and 1. Everything you have transformed. Now this is very important thing. Now here you have to divide your complete data set into the two parts, and these two parts are known as the X train, X test, Y train, and the Y test. As I told you, the model needs to be trained. So if you want to train your model, you have to do what? You have to train from the complete data set, a certain portion of the data set you have to keep it for training purpose. So X train and X test. So what I did, 614, 8. 614, so I have split this data. First of all, train test split into the 4 parts. I have kept test size 0.20. 0.20 means 80% of the data set I am going to use for the training purpose. But the 20% of the data set I am going to use for the testing purpose, whether my model is good or not. So I have taken the input variables 614 samples. I have checked with this one, and I want to know that what prediction my model is making on the training shape. This without a value, this is known as, this is the Y test and the Y train. So this X train will map to the Y train. These values are with us. Now our model will take this Y test and it will predict whether this 154 values are yes or no, 1 or 0. This is known as the checking the accuracy of the model. You train your model, you divide your data set into the 2 parts, one into the training part, another one into the testing part. You train your ANN model based on the training part, X train, Y train. You test, you don't show the output to your model. Your model will predict what will be the Y test value, that is known as the Y prediction. And you check with the Y test whether your model has predicted the correct Y test value or not. That decides the accuracy of your ANN model. So I'll skip all these things. I wanted to cover all these things. So import TensorFlow as TF. And this is the TensorFlow package has been provided by the Python for building the artificial neural network. The Keras is another package where you can import the models. The sequential means feed forward, layer by layer you can go. The Keras.layers is the import dense. Dense is also the package. That means all the layers are connected to each other. This pandas and numpy I already explained. Import CSV. Here you have taken the input. This PyMy Indian database, this diabetes data set I have taken. I have read, and this is my data set. Now what I will do, I will divide my complete data set into the 2 parts, that is the X and the Y. From X, I can take only the 2 parts, and this X is what? This is the input parameters from 0 to 8. So what is 0 to 8? So my X will contain, I'll just show you, my X will contain these columns. This column: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and a function, and age. And my Y will contain this outcome variable. This is what I want to show you in the X and the Y. So you have divided into the X and the Y. So first 8 columns will go for the X. Those are the input parameters, and the output parameter will go to the small y. Now this is the way I am going to create my artificial neural network. So model is equals to sequential. So model is equals to sequential means my all the layers are there, and that is the input layer, and then hidden layer, and then the output layer. Sequential function is there to create the model. Then I will add the layers. Depending so how this structure of the model is, the model dot add. So model is sequential. What is the meaning of sequential? I just told you. That is it is the layered model, sequential model. After the input layer, hidden layers will be there. After the hidden layers, the output layers will be there. And model dot add means I want to add the layers one by one. So how I am going to add? Just carefully you observe, and this is very important thing. The model dot add dense is also a package. What it is taking, it is defining the input layer. This input layer is having the input dimension of 8. There are 8 columns in my data set. That is age, pregnancies, skin thickness, BMI, all these things have been mentioned there. So how many input parameters are there? That will decide the input dimensions. So these input dimensions have been clear, and these input dimensions are with dense layer 12. That means just following the input layer with first hidden layer, that first hidden layer will have the 12 neurons. In my input layer, there are 8 neurons. My first hidden layer will have the 12 neurons. And from input layer to the first hidden layer, my activation function will be this ReLU. And this model is added. So 3 things this has done. The first thing has been done by the input layer. My input layer is 8. 8 neurons are there. My first hidden layer is having the 12 neurons. This is dense. That means all the input neurons are connected with the 12 neurons. And on this input layers, the activation function has been applied as the ReLU, and that will generate the intermediate output. That intermediate output will go to this layer. I am adding one more layer where the 8 neurons are there in the hidden layer 2. That also working on the activation function ReLU. And one last layer I have added as the output layer. It is having 1 neuron, and the activation function is the sigmoid. This sigmoid will give you the outcome between 0 and 1, and this 1 neuron is showing the output layer. Output layer will have only one outcome, whether the person is diabetic or not. So this is the way I have built my ANN model. I have to compile my model. I have to define the loss. I have to define the optimizer. This is the gradient descent algorithm. and my metrics for calculating the accuracy of my model is the accuracy. Loss should be minimum, optimization should be optimal, so loss will be less, and I will check whether what is the accuracy. This model I am going to fit on my input data set, and y is the outcome data. I have to function this on the epoch 100. Epoch 100 means 100 times I will give this training set to learn the patterns and to predict the outcome. And the batch size is the 10. And the batch size 10 means that 10 times you can shuffle in a different way, and the same input you can provide to your model to learn. This is very important. This is very important. One by one, I'll just take and I'll just and I'll show you. So these are the outcome. This final epoch. It will go from 1, 2, 3, 7, 11, 12. As you can see, so 100 times I have executed, and the final accuracy has been achieved as the 70.96. So this is the accuracy parameter I am getting. That means out of given 100 inputs to the unknown parameters to the ANN model, 70 times my model has predicted perfectly. You can change the epoch value, you can change the batch size value, you can change as per your convenience, or as per your whatever the results you are getting for that. Along with this, some parameters are there to check the accuracy of the model. Those are known as precision, recall, F1 score, and the support, and it gives the accuracy like this. Your F1 score is the average of the precision and the recall. Precision is the positive, average positive cases, and the recall is the similarly the true positive rate and the true negative rate. Means whether if suppose someone is diabetic and your model is predicting that particular person is diabetic, this is known as the true positive. If someone is non-diabetic and your model is predicting that he is not diabetic, then it is known as true negative. Similarly, the true similar to the true positive, true negative, the false negative and the false positive is also there. False positive means he is non-diabetic, but your system is telling he is positive. So this is known as the false positive, false negative. So these are the formulas for calculating the sensitivity, specificity, precision, negative predictive rate, fallout, false positive rate, and false discovery rate, and you can calculate all these parameters, and you can go for another matrix that is known as the receiver operating characteristics. The same data set I have applied for the linear regression also. So whatever this area under the curve will come, here 0.77 is coming, that means 0.77 is the positive aspects of that one, and very less is going beyond that. So more the value, more the accurate is the prediction. So this is how we have calculated this is how we have built the model, and this is how it works. So now I am closing the session. Hopefully it gives you the overview of the ANN, how to build the ANN, and how to predict the real world problems using the ANN. If you have any doubt, you can ask. Thank you very much for your patience.
Sir, there are 2-3 questions in the chat box. I will read it out for you.
Yeah.
Okay.
Yes, sir.
What is the difference between data processing and data exploration?
No, actually, the data processing is the actual process where you are deciding your test size and the training size, and you are fitting your data. And data exploration, you are not doing anything with the data. You are just visualizing the data. You are getting the insight from the data, that how many missing values are there, what is the distribution of your outcome variable, is there any outlier in your data. When you are not doing anything with your data, just by looking at the data pattern, by visualizing your data with the different plots, then it takes you to the, or give the more understandability of the data. Where data processing means, after finalizing the data, you are building your model based on that data. That's the difference.
And sir, can you share the Jupyter notebook for the participant?
Yeah, definitely, sir. I'll share.
Okay. Okay. Participant, if you have any doubts, then you can unmute yourself and you can ask the question.
Hello, sir.
Yes, sir.
Sir, already we have installed the Jupyter yesterday. Vipin sir sent some video.
Yes, sir.
When we type that import pandas ASPD, it says that no model named pandas.
No, actually, you have to go to the Anaconda command window,
Okay,
and there you have to type pip install uh,
okay,
all the packages, whatever you want to write. The flow I have already shared with the sir, Vipin sir.
okay, sir. Okay, sir. We'll get it and follow it.
Yes,
Thank you, sir.
yes, sir.
Sir, hello.
Yeah, madam.
Sir, how to decide
Yes, ma'am.
number of hidden layers?
Madam, number of hidden layer and number of weights for that, and number of the neurons in the hidden layer, it completely depends on the user. So as I told you, there is no thumb rule for this, but you can decide, because various parameters also important, that whether how much time it is taking, what is the accuracy, and what is
Okay.
the cost for that, what is the error. So based on this, you can limit the number of layers and limit the number of neurons in each hidden layer.
Okay, sir. Okay, sir. Thank you, sir.
Anyone else wants to ask any question?
Sir, kindly suggest some good books for this program.
Sir, I will share some good e-books with Vipin sir. I have some e-books, very good e-books they are. So I'll share with sir.
Okay. I think now participant has don't have any doubt, so we can end the session. So we are on behalf of our
Yes.
institute. We are very grateful to Dr. Harshvardhan Tiwari sir for enlightening us with this brief knowledge about ANN. So
Yes,
now,
thank you very much, sir. Thank you very much, Vipin sir, for your kind cooperation and for organizing everything. And thank you for the participants also for patiently they have listened to me. Thank you very much, sir.
thank you, sir.
So can I leave this meeting
Yes, sir.
now?
Now you can leave.
Yeah, thanks.
And participants, now we'll have a break of half hour, and the next session will begin at 12.
12:30.
At 12:30, so we will have a break of 1 hour, so kindly do join before 12:30 for the smooth start of the session. Thank you.